Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, let's just say the limit. Let's just say the whole limit here is y, and we're going to try and work out y. So from here, take the natural log of both sides. That will then give you this. Take the natural log of this. This will come down here. That will then give you this. You've got your natural log here, natural log, and then you've got this. Well, from here, take the natural log of both sides. That will then give you this. And then here you've got one block multiplying another block. This block here gets multiplied to the top, giving you this. And then now check it. So as n tends to infinity, this thing here, as n tends to infinity, this thing here will head towards infinity. Natural log will head towards infinity. As n tends to infinity, this thing here is going to head towards 0. As n tends to infinity, 1 over n will head towards 0. So 1 over n will head towards 0. So it's going to do this. The numerator will head towards negative infinity. The denominator heads towards positive infinity. So here you've got infinity over infinity, which is an indeterminate form. So you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate the top. That will then give you this. Differentiate the bottom. That will then give you this. So when you differentiate this, it will be 1 over the bubble, 1 over n. So that's the 1 here, 1 here, 1 over n, 1 over n. And then you times the derivative of the bubble itself, which will be minus 1 over n squared. So you visualize this this 1 over n as n to the power minus 1. So this goes down, blah, blah, blah. Well, differentiate this. It will then give you this. So now it's just a matter of tidying this up. Tidy this whole thing up. It will give you something like this. And then now you've got exactly the same divided by exactly the same. So that's going to be 1. But then you've got a minus here. So that's going to be negative 1. So the limit here is negative 1. So now from here, e equally to both sides. That will then give you this. And then these two in a way cancel each other out, giving you this. So the limit is actually 1 over e. Okay. So next question. So find the limit of this. Find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay. So to do this, let's just say the whole limit here is y. Let's just say the whole limit here is y. Take the natural log of both sides. This n will come down here. That's this n. You've got your natural log, and then the bubble here, the bubble here. So now let's check it. As n tends to let's try and evaluate this limit. As n tends to infinity, so here you've got one block multiplying another block. As n tends to infinity, this is going to head towards infinity, and then this thing here, as n gets bigger and bigger, this thing here is going to head towards 1. This whole thing here is going to head towards 1. So if you look at the natural log graph, 1 is here. So this block here will head towards 0. Will head towards 0. Will head towards 0. So this block here is heading towards infinity. This block here is heading towards 0. This is an indeterminate form. So whenever you have a product indeterminate form, we would use this trick and rewrite it as 1 divided by 1 over n. So here you've got a product. You've got a product. One thing multiplying another thing. So the trick that we've always used in the past is to rewrite it as a fraction. You've got one thing over another thing. These two are exactly the same, just written differently. So now let me think. Now let's check it. So as n tends to infinity, this whole thing here is going to head towards 1. So natural log of 1 is going to be 0. So this thing here is going to be 0. As n tends to infinity, this thing here, this is going to be very, very big. So it's going to be 0 over 0. This here is an indeterminate form, so we can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate this. That will then give you this ugly thing, and then differentiate this. That will then give you this thing here. So now, but by the way, to differentiate this, in your mind, well, in your mind, visualize it. Well, if you differentiate this, it will give you this. Okay, so well, when you differentiate this, it's going to be 1 over the bubble here, which is 2n plus 1 over 2n minus 1. Reciprocal of this thing, well, it's going to give you this, and then you've got to times the derivative of the bubble itself. Well, the derivative of the bubble itself is you using the quotient rule on this thing here, which is this. So and then differentiate this, that will then give you this. Okay, so now it's really a matter of you tidying this thing up. So to tidy this thing up, so to tidy this up, so this is like one bubble. Well, here you've got, well, this would cancel out with this, and then well, tidy up. This would cancel out with this. Tidy up, it will give you something like this. Okay, and then now multiply this. But this times this times this, and then this times this, and then this times this. That would then give you this whole thing here. Multiply this, that would then give you that. And then here you've got these two would cancel each other out, and then you've got minus 4 here. You've got minus 4, but then use this minus to turn it into a positive 4. So that would then give you positive 4n squared. What's at the bottom will be this. So now as n tends to infinity, it's going to be as n tends to infinity, you can visualize this as this, and then as n tends to infinity, this number 1 is insignificant, so it's really 4n squared. You can consider this thing here as 4n squared. Well, that's really, the limit will be 1. So the limit will be 1. So now exponentiate both sides. That will then give you this. And then, so y equals e. So after all that, y equals e. Okay.